Oh, that's a problem. I might be out of analogs. I might... Okay, no, that's one. What's going on, everyone? We're doing something a little bit different today. We're going to look at a STEM or STEAM education kit from Elecrow. The lovely people there reached out to me ages ago and offered to send me this. Now, what you likely don't know is I also work in another company with my brother, and we deal with a lot of schools and educational institutions, and specifically we're dealing with technology in schools. And we love seeing stuff like this, things that can get students into technology, into AI, into robotics, into programming, into manufacturing, into design, into assembly, into any part of what actually makes the world tick. Now, I was hoping to do this with one of my mates' kids or even the missus, but everyone's just been too bloody busy. So I've delayed long enough. Elecrow sent me this probably 6 months ago, back in October, and according to my schedule, I told them I'd film in May. It's April now, so I mean I'm off by about 12%. That's not too bad. But this is their Crowtail Deluxe kit, and I haven't even opened it yet. I started to, and then realised what it was. Now, it's Australia. It's apparently permanently summer here now as well. It's a beautiful 30-degree day on a Friday. So I'm going to have an unboxing of this, and we'll look at what's involved and what it's got in there, what you can do with it, and then probably assemble something too. But if this is actually a bigger project, this might be a 2 or a 3-part video. Now, after this one, if it is going to be part 1, I would love your feedback on a couple of things. One, what do you think this could do that its documentation doesn't have as what it should do? 2, what do you want to see me do with it? Is there something that I missed? Is there something I didn't explain? I would always love to explain that. And 3, let me know about the audio and video. This is the first video now that I'm going to be recording in B-RAW as opposed to ProRes. But I'm also filming in HDR as opposed to SDR. So it's going to be a little bit different. It's something I haven't experienced before. Hopefully it looks awesome. Might look shit. So without further ado, I'll have a mouthful of my spicy drink. I'll play an intro scene if I've made one yet, and we'll open this up. Bubble wrap. Always love bubble wrap. And no joke, I do, because I have an e-com site or an online shop where I sell SBCs and modules and accessories and sensors. I sell lots of this sort of stuff, and I might start stocking Elecrow stuff too. So if you want to see more of their products in my shop, let me know. And you might even get it wrapped with this bubble wrap, because I hold on to it. I like to recycle as much as possible. And my shipping policy even says that I will recycle the packaging. Waste not, want not. Oh yeah. Look at that. This is awesome. The rest of it's just the box. So that can nick off onto the floor. I'm going to try to swear less in this one because I do want it to be aimed at children as well. What we have here is the Crowtail Deluxe kit for Arduino. So they've got quite a few different kits with different amounts of modules in them, but also designed for different purposes. So Crowtail is kind of the kit name, Elecrow, Crowtail, you know. And what I've done is I've got the ESP-Duino. It's essentially a Arduino Uno board for it. So you can get all sorts of different kits, pair them with different boards, and design whatever you want to design. In this case, from what I understand, it makes some sort of little AI car, and I'm pretty excited about that too. So I'm going to go grab a cloth to wipe this table down because I didn't realize it's sticky as hell, and I'll be right back with you. As one tick. All right, we're back. Unfortunately, I use this table for a lot of 3D printing as well because it's portable. It depends where I'm going to be doing my printing, and it must have had some of the SLA resin on it. Now, I also just noticed that these are out of stock at the moment, but I'll put a link below to them because they're only $69 US, which for what you get is really, really good. I could also, of course, learn this entire product in its entirety and then show you how to use it, but that's not really what this channel is about. What I try to do with everything here is show you the experience you're going to have when you receive it and you open it. So we can learn together how to get through any challenges, pitfalls, difficulties, and what exciting things there might be. Similarly, if you do like this, don't forget to hit the like button below because that shows me that you're enjoying this content, and hit subscribe and the little bell if you want to be alerted when I make more videos like this. I'd also appreciate, as I said before, any comments. I don't do this to make money. I do it because I enjoy these things, and I love companies like Elecrow who engage the maker community, like myself and my friends, who do open source hardware and who support education. They are really, really good, and they're continually improving. So How the hell do you open the box? Okay, it's got, oh yeah, we got a little seal of authenticity there. Seal of bloody good stickiness. There we go. Now, so far, the box quality is really good. So is this. This is, God, I hope I got the camera in focus. It looks like it is. This is excellent. So I've got a really rigid box with some beautiful branding on it. I've got some little logos along the front that show you what this is. So it's logic and thinking, programming, Arduino, STEAM education, electronic experiments, plug and play. These are all the sort of things that you're going to want for anyone learning maybe between the ages of 8 and 16. I'm not. I'm in my 30s, but I'm still a bit of a slow. So we'll have a look at this, but they then have a kind of almost 3D model of the box. So you can see you've got IR emitter, reflective sensor, 3-axis digital accelerometer, IR receiver, analog gyro, switch, buzzer, hall sensor, collision sensor, motor base, ultrasonic ranging sensor, Crowtail RGB LED, thumb joystick, TT motor, 9G servo, user guide, one-wire waterproof temperature sensor, ESP8266 Node MCU. Oh yeah, that's right, I picked that out. I've never done anything with Node MCU, so I think that could be very fun. This will almost certainly be a 2-part at least. Nice little LED screen, BLE module, I2C EEPROM. Now that's actually pretty cool. I treat that separately. LED, bright LED, reflective sensor, when we're back to the start. And then this little module. So it even tells you where to open it on the side. Excellent packaging there. Now I can't remember the reason for there being 2 separate things. I'll have to check my emails, but I'm sure we're going to learn as we go. And either way, this is a nice little Arduino module. Takes mini USB, DC jack there, and we've got a whole pile of headers. So that's likely going to, oh, I see, yep, that kind of lines up. These motors are pretty beefy, so they're going to be our driving motors. Got some headlights, joystick, so I assume we're going to have a remote control, which is pretty cool. Oh, awesome little button there. Thank you, Elecrow. Sensors, wires, it's everything out there, so that's really cool. And that's the user guide. Ooh, free edible. It's not, don't, Americans don't eat those, they're not good. I know we shouldn't have to say it, but it says on there, do not eat. It says it in quote marks, actually. It's kind of implying, you shouldn't, but you can. Don't. It's not good for you. We shouldn't have to tell people about that. Alrighty, so I'm going to have a look at this my way up, and I'll probably flip it around on the video for you to see it. I'm recording this in over 4K resolution. I think I might even be recording in 6K resolution, so that gives me a bit of room to zoom in. We'll have a look. Oh, all right. That's pretty insane. It's broken down into an overview of the instructions, the modules lists, how the Crowtail part of it works, and 20 lessons about all the different modules. I don't know if I can fit this in 1 or 2 videos. This is something where a teacher should learn this through and do like a 3-month course in a classroom, like once a week, do a 1-hour module with students. This is really cool. I've got a friend who's a teacher, actually. My mate that lives around the corner, his wife teaches, so I might get her involved with some of this at one stage. So I've got the base shield. That would be this one here. These are tight fit. That's pretty good. Oh yeah, and on the bottom. So for those who want to use the Arduino to build their own DIY platform, motor drive has always been a problem. You need to use 2 DC motors to at least to control their speed and direction of rotation, because you want your platform forward, turn back, turn left or right. Besides, motors always needs a large current, so you'll have some modules to help you with a large current with a microcontroller such as an Arduino. Then the motor base shield appears. It can meet all your demand in DIY mobile platform. All right, this is pretty Chinglishy, but it's pretty good. I'm accidentally filling in the blanks a little bit here, but you'll get the idea. It's a standard I/O expansion motor board for the Arduino. It relays the I/Os to the standard Crowtail interface and have 2 interfaces to drive the motors. All right, that's pretty cool. So, yeah, gotcha. I see. So that's why this came in a separate box. So we're essentially using an Arduino Uno. They're going to be running Node MCU on. And as you can see, this Crowtail base, it's essentially the first step, I guess. You've got your Arduino base and you slap your Crowtail module on top, and that creates kind of the brains and the heart of it. Brains, heart, at least in my understanding. Gives you a whole pile of ports here as well and passes most of those headers on. Now, interestingly, you see how the pins line up, but there are some pins that aren't being used as well. A little bit curious. It's good that they do have on the bottom all the pinouts on the PCB. That's quite nice. And the microcontroller on this is a STL298P. So very interesting design choice there. They then make more than 100 kinds of modules. So we've got 26 or so in this box, but over 100, which is excellent. So you can likely buy expansion kits or add-on kits. This is like the electronics of Lego, and I'm getting more and more excited as I go. Lesson 20, a remote control car. So if you have a good understanding of our electronic modules, then you must know that our modules can meet almost all your needs for making your own smart car. It's time to start making our own car. In this lesson, we'll use the infrared remote control to control the car. Make a simple remote control car through the infrared emitter and receiver, button, buzzer, motors, LED, and so on. Less gossip, let's start making. I call it as I see it, and I'm seeing one thing lacking here, Elecrow, and I don't know if it's just me. As I said, I'm a bit thick at times, but cars usually have a frame or a body, and in this diagram here, as lovely as it is, you've got the remote control, and it looks like this might actually require 2 kits, but I might be able to use this for the remote and this for the motors because the motors require a bit of current. But you're kind of missing 2 things. You're missing the body or the frame of a car, and you're missing wheels. I think wheels are pretty important, huh? So part 2 will likely be building a little frame of a car, but I'm going to have a look at this now and see what I can fit together. Interesting that this is also geared now. In the original kit, I don't think it was geared. And build some of the basic stuff and see what happens. So I'll get back to you shortly. Hold, please. Alright, here's just another little caveat. Whilst most of it do use pretty standard connectors, these geared motors, as awesome as they are, you'll want to make sure that this bit of rubber is actually kind of attached. I don't know if it matters if it's on there properly, but yeah. You're going to need to solder to these, so they do give you some jumpers, which is good because we'll screw them into the header terminals. Terminal blocks. Couldn't think of that word before, bloody hell. Sorry, children, don't swear, stay in school. So they do give us the right amount to connect to those. The other thing is, it says that the motor shield is going to need additional power. So if we go back here, it doesn't actually say it there, but at the very end, oh, well, it. Because the motor consumes more power, after uploading the code, you need to provide additional power for the Crowtail motor base shield. Usually connect 9-volt power supply for the power input port of the motor base shield, then turn on the onboard power switch. Reset, on, off. All right. So that takes some juice too, by the looks of it. Complete the connections as follows. All right. that's all well and good. So we are going to have to solder that. I'm going to grab this little, got these little soldering irons. One tick. All right. So in the store, you might have seen, I got these cheap epoxy USB soldering irons. They actually work though. It's got me a little bit dumbfounded, but of course I bought them essentially for stock because they're cheap, and I thought these have got to be poo. So I unboxed one. They got this weird USB to kind of almost TRS jack there. They do come with a little stand. They come with a bit of solder and they got a cap. Incredibly, they work. It's kind of confused my noodle a little bit. So pretty much just plug her in, hit the button, and in a few seconds you're ready to solder. So I'm going to split these headers in twine, and I'll see if I can nicely and easily get these soldered on. Apparently this just takes like 15 seconds to heat up as well. The challenge here is these copper pads look a little bit tarnished and dirty. Yeah, that's hot. Don't melt the plastic. Not good for your soldering iron. All right, a little bit of tinning going on there. Not an exciting amount, but might just be enough to get us by. Should probably stock some solder too, but later me problem. A little bit more tin on that one. So Elecrow, if you're listening, besides including a motor base and some wheels, including some solution here would probably be really good, and like a USB drive with the code might go down a treat too. That one does not want to take. It's also hard without my helping hands here. There we go, that's looking a bit better. If I had my hot glue gun, I'd also hot glue this afterwards, just because these little copper tags coming out the DC motors are a bit fragile. This time I'll quickly pre-tin those just to make my own life easier. These tin up quite nicely. Have an extractor fan on if you can as well, folks. It is not ideal to not have an extractor fan. Well, for soldering that is. Alrighty, those are attached. Little soldering iron did a good job. I obviously do need a small screwdriver now, and this doesn't come with a small screwdriver in it. That might make it easier for shipping and customs in some places, but I've received so many things that do have small screwdrivers, so I'm just going to grab one of them. Again, something else I've got in my store are these little camera modules. These are for the Cyped. Pardon me. These are for the Cyped Lychee RV Nano, which I've got a dozen of or so, and they're a pretty sweet little camera module, but they come with a tiny screwdriver. So it's a bit bloody handy. And it just fits. What a win. I don't know if you guys watch my other YouTube channel much. I do a lot of cooking, kitchenware reviews. I love cooking. But if you do, you'll be familiar with me just not reading the instructions. Usually I pick up something like this and off it goes. But in this case, I want to see what you're supposed to do. I do reckon that this is a pretty neat little kit. So I'm trying to do it by the book to some degree. You're just going to have to bear with me. Yeah, we go back through all of that. I'd recommend doing all these courses, of course, or horse, of course. Where's that from? But we are going to jump straight to the meat of it, which is this little car. And at first, we're connecting these bare minimums. So we've got the light, the IR sensor. At the front there, you're going to have Why is the collision sensor on the joystick? We've got an LED, collision sensor, button, and joystick on the remote part. That's a little bit weird to me. What I'll probably do is I'll move the collision sensor across to this, probably put it on the back, put the ultrasonic rangefinder on the front. Now what's that? That's going to be the little buzzer module. So let's just wire that bad boy in. That's going to be on front left. So if that's oriented that way, that one goes there. These cables are a little bit long too. I'd like to see shorter cables. So we're missing an actual body for the car, wheels for the motor, power input, a screwdriver, and some shorter cables. I will jump back on the Elecrow website, and if I've got them, I'm going to order them as express shipping to get them here quickly for the next one. Now, if we're going to use this then for the remote, which I'm assuming is the purpose, when the lovely rep Annie told me that I'm going to need to get more than what just the kit comes with. For the remote, I see digital, analog, digital. All right, that's cool that it does tell you that. This one is meant to connect there. Is that? It sort of ports that. That's digital. No, it's that one. Analog, A4 and A5. All right, that makes sense. So you got X, Y, DC in there. So we're going to need that on an analog port. It's going to be there. I think that might be our only one. And what do we need the button for? Infrared collision sensor. When you press the collision sensor, the button will beep. Press the switch. All right, so the switch, this one, we're going to use to turn the LED on and off, essentially the headlights. That's cool. Get out of the box. Now, this one is ground, VCC, no connect signal. The button, it wants to connect to that, which would be digital. All right, we've got a digital spare on here. Digital button, makes sense, on off, it's a binary operation. I'm not going to bother with the collision or the LED on here. I'm going to turn the headlights on and off with that. Control the direction and the speed with that. So what I'm then going to want to do, if I'm going out, again, I'm just not doing what the, I'm not doing what the box says, but that's all right. The ultrasonic rangefinder would normally go on to digital. Got another, oh yeah, we're going to attach that here, so that's all good. So if that's facing that way, we want the ultrasonic rangefinder to be on that one, which is spare. That will go on the front to tell how close it is to something. Collision sensor we'll put on the back in case we reverse into something. What sort of connection does the collision sensor usually use? Page numbers would be awesome, folks. Page numbers. It's oh no, that's the modules list. Don't worry, I'm dumb. Your page numbers are there. Collision sensor 7. That's the second experiment. That normally goes onto a digital connection. I think we got one of those left. What's that? Analog, 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 digital. Oh, one digital left. Oh, don't know what we're going to do about that. We might have to hijack some pins from elsewhere. What else did I want to add on? I want to add on this LED module. Now this is I2C, I2C, whatever you want to call it. I'm assuming we've got a port on here for that. Analog, 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 digital, digital. Oh no, I've got some more digital left on there. This will probably just go on pretty much any digital pin, and we just have to map those pins in the software. 19. This is cool. I'm really starting to enjoy this. Early to analog, A4 and A5. That's really interesting. Not what I expected, but I can definitely do that. Why the analog ports? It must be those ports can, you know, have the I2C assigned to it, so you map them in the code. That would be my best guess. So that's going to go on the roof of it. And then we're going to want our headlights. We're also going to want these on the front, probably above the rangefinder, so that we can have, you know, headlights and indicators. Oh, and a brake light on the back. We've got a big red LED here. We want a brake light on the back, and these are going to be our last two cables. So the these RGB LEDs, how do they connect up? 17, I was just there. Once they want a digital, lucky, plenty of digital free. I mean, we've got plenty of everything free. That's kind of cool. This is gonna need any digital pin should do it. Actually, it's using NeoPixel, so I'm just gonna slap that on D6. Roller D6. I don't know if you know that rip off or cover song. It's pretty cool. Put a link below if I remember. I never remember though. And then lastly, what have we got? We got the Bluetooth module. I mean, that would always be cool. We can maybe do that in another one. We are quickly running out of wires. I'm going to need to get more wires. I'll probably get some short ones if that's an option. We have left LED, IR emitter. Oh no, that's an IR emitter. Yep. And I2C EEPROM, analog gyro, and a collision. No, I already took the collision sensor out, so that's the Hall sensor. All right, so we've got it moving, we've got it range finding, we've got it detecting collisions backwards. We're going to put our rear light on. And for this one, this will be analog. Got some of those left, so I'm going to slap that on A1. So, all right, we have most of our car here. Let's clean this up a little bit, show you what we've got, decide where we're going to go from it. We essentially have our remote control that doesn't have that IR emitter attached yet because I got the dumb. So we need another cable to attach that, or we have to sacrifice something cool that we're doing over here. Then that needs power and does its own thing, which is pretty cool. Over here, we have our wheels, our front rangefinder, our rear collision sensor. We have, I mean, we don't really need that light on it. We can probably pull that out and use that cable over there. A brake light, the IR receiver, and our headlights, which will also be indicators. So the next step, folks, is definitely going to be a multi-part video. I'm going to have to knock together some sort of chassis for this, unless they've got one on the store. I'll use that. I'm going to need some more cables, power, wheels. I already got a screwdriver, and I think that's it. So whatever they have, I'm going to go buy from their store now. I'm really excited about making this do a thing. I think it's pretty sweet. It's got all the mounting points that you want. It's got nearly everything you need. I'd love if there was a version of this specifically for making the car, like a Deluxe AI car kit that came with the body and the wheels and everything. So maybe you could start through this, and then a part 2 kit would include that. I'd love your feedback on this. I'm going to keep these assembled as it is. I'll decide what to do about that LED module. I'll probably actually take it off and use this wiring over here for the IR device. That makes sense. Don't forget to like and subscribe. I'll put a link below to all of Elecrow's stuff because they make good stuff. There's no other way to say it. They're also a lovely team. Let me know what you think. I'll likely do the next video in 2 weeks. Next week's video, if I get some time, will be another SBC. I think it'll either be the Luckfox Pico Max, which is an awesome product. Link below. I've got 100 on the way from Luckfox in shipping at the moment. Or I might do the Radixa Rock 3A, because I've been playing with that a fair bit, and it's a pretty awesome little device too. So I hope you're all having a great, whatever season it is there, good weekend at least, because I should get that out this weekend. And, oh, that's a problem. I might be out of analog, so I might, okay, no, that's one. I hope you're all looking after yourself. Till next time, take it easy.